2, 1. Hello everyone, my name is Suat and this is my project partner Şirvan Kesici.
Hello, I am Şirvan Kesici.
In this project, we developed a face detection system in real time with using Raspberry Pi 5 and Raspberry Pi camera module. The goal of our application is to detect human faces in a live video stream with minimal latency using lightweight algorithms suitable for embedded systems. Our approach relies on classical computer vision rather than modern deep learning models, which makes the solution highly efficient and computationally inexpensive, ideal for low-power devices like Raspberry Pi. Our project not only showcases the potential for embedded computer vision, but also explores the trade-offs between model complexity and hardware limitations. And let's continue with the implementation of the machine learning model. We didn't train any machine learning model from scratch. Instead, we used a pre-trained Haar Cascade classifier, which is a classical computer vision model included in the OpenCV library. The model is based on the Viola-Jones algorithm, which uses a combination of Haar-like features, integral images, and a cascade of weak classifier trained with AdaBoost. It is one of the earliest and most efficient face detection methods, still widely used in embedded and mobile application due to its speed and low computational demands. The classifier is distributed as an XML file. In our case, Haar Cascade frontal face default.xml is used, and my friend Şirvan will show the file when he is continuing to explain. This file contains the trained feature structure and thresholds that allow face regions to be identified in grayscale images. Since the model is already trained, we didn't use any datasets and there is no information to provide regarding architecture, input-output features, or epochs. But normally our input is grayscale images frames captured from the live video stream, and output is a list of bounding boxes indicating the detected faces. Instead of accuracy and confusion metrics, we use inference speed, which is FPS, as our main performance metric. On Raspberry Pi 5, our application achieves a frame rate approximately 15 to 20 FPS, and which is sufficient for real-time interaction in most use cases.
I will explain the model deployment on the embedded device. Firstly, the deployment process for our model is extremely straightforward due to nature of the classifier. The pre-trained XML file and is stored locally on the Raspberry Pi 5 system. During runtime, it's loaded into memory using OpenCV's CV2 cascade classifier function. No model conversation like ONNX or TensorFlow Lite or optimization like quantization or pruning is needed, and which reduces development complexity and speeds up integration. We use this project for when we don't need to internet connection on the other structure. We use this project successfully. Since the Raspberry Pi 5 has sufficient RAM and CPU power for lightweight tasks, we were able to run the application smoothly without any external dependencies. This direct deployment makes the system more portable and reliable for offline or remote scenarios. Access and cloud computing are not available. If I will show this scans how we'll use Raspberry Pi 5. We use software of the Real VNC viewer. Then we connected IP to computer and computer. Then we use the password. After that, we will successfully log in. Then we download this project from GitHub. For downloading, we have codes and we use this command for Linux command. Then we have code about how we can download the project from GitHub. After that, our project downloaded this file, Raspberry Pi object detection. After we will open the face detection Python programming. For this project, we use this code, and Suat will explain this code details. If I say some summary things about this code, the interface page begins as soon as the application is executed. And for this project, we use Raspberry Pico 5 and Raspberry Pico camera module, and depending our hardware availability. Each captured frame is immediately converted to grayscale, which help reduce computational load and improves detection speed. The grayscale image passes to detect multiscale function. This function slides a detection window across that match the patterns encoded in the higher cascade. I will show how we will run this code, and when we see the project. This code shows our face detection in the square. After this process is repeated for every frame until the user presses the SAGK to terminate the application. Okay, Suat.
And let's continue with the code. Our code is written in Python 3, and it uses embedded Linux system like Raspberry Pi OS. At the beginning of the script, we import all required libraries such as CV2, NumPy, and Time. We also check whether the system is using a Raspberry Pi camera or generic webcam and configure the video capture accordingly. The core of the face detection system lies in the cascade classifier function, which loads the XML files from disk. In the main processing loop, we perform the following sequences. At first, the video capture a frame from the video stream. It converts the frame to grayscale, and after that, it detects faces using pre-trained model, and it draw bounding boxes around each detected faces. And after that, it measured the time taken the processing the frame, which is FPS, and it's calculate and display FPS in the video output. And the output is displayed using OpenCV GUI window, and the program runs continuously until user intervention. And this structure reflects the best practice of embedded vision system, prioritizing speed, simplicity, and minimal hardware requirements, all while delivering functional and interactive results in real time. And thanks for watching and listening us.
I will show how can we run this code. I use the Genie for this project, and you can see this is working correctly, and this blue square detection of my face. Yes, you can see. And I want to show our Raspberry Pico. Just wait a moment. So, can you see the Raspberry Pico and the camera?
Yes.
Okay, that's all. Thanks for watching
And listening us. Thanks.
and listening.